All right, guys, it's Mr. Katz. I just wanted to go through the actual video for lesson 10. This is pretty much exactly what we did in class. And at the end of the lesson, we're going to do numbers 2 and 3 from lesson 10, which you'll find on, it's somewhere, it's either page 48 or 49 of your packet. We'll talk about the connection, the aha moment you should have got from the lesson, and then we'll give you one practice problem. So this is the problem for number 2. It gave you an equation, and this is, remember, in factored form. And it asks you to do these four things. Find these four things about this equation in factored form. So we learned that there's a trick to doing these four things, but we learned how to do it on your calculator first. And the first thing you want to do is, in order to find the vertex or the line of symmetry, we're going to go ahead and we're going to actually multiply number 2 out, which means we're going to put it in standard form. So you can either take half of this one or this binomial, but neither one of those, both terms cannot be cut in half. And right here, these, you'll get a fraction. So what we'll do is we'll multiply x minus 2 times x minus 6 first by distributing the x, then distributing the negative 2. So the first, that will become x squared minus 2x minus 6x, and then positive 12. And then remember that, so this combines to be x squared minus 8x plus 12. And then you remember you have the 1/2 on the in the front, so you have to distribute the 1/2, and eventually you get 1/2 x squared minus 4x plus 6. And this equation is now in standard form. So in order to find the line of symmetry, well, that's the x equals, and we got to find the x coordinate of the vertex. So we could do that one of two ways. The first way is we can actually use the formula negative b over 2a. Remember, this is your b, this is your a. So negative b over 2a would mean negative negative 4, which is a positive 4, over 2 times a, which is 1/2. So 2 times 1/2 is 1. So you get an x coordinate of 4. So the line of symmetry would be x equals 4, and that means our vertex is going to be 4, our x coordinate of the vertex. To find the y-coordinate of the vertex, all I'm going to do is I can either substitute in a 4 in for these x's and solve, or I could actually technically do it into these x's and solve this whole thing. I'm going to go ahead and use this one right here, the equation in standard form. So x squared is 16. Then 1/2 of 16 is 8. So let me write that down, 8. And then minus 4 times, and then again, it's the 4. So 8 minus 4, you got to do the 4 times 4 first, order of operations. So 8 minus 16, and then plus 6 at the end. 8 minus 16 plus 6, you get negative 8 plus 6, which is negative 2. So our vertex is at 4, negative 2. If I wanted to do that same thing, find the vertex without using this formula, negative b over 2a, and I'm going to go ahead and erase it right now, so make sure you rewind back if you need it. But if I wanted to do from the beginning, I can put my original equation, either the one in factored form or the one in standard form, into my calculator. And here we have, it was 1/2 x squared. So 1/2 x squared minus 4x plus 6. I'm going to hit graph so I can see my graph. And then to find the vertex on the calculator, this is a minimum vertex. So I'll go to second trace, which is calculate, my minimum, which is 3. Left bound, remember, means to the left of your vertex. So if I go to my vertex and just hit over left a couple times, you can see that the left is this way. And then hit enter, right bound. I'm going to go to the right of my vertex. And then guess, I'll hit enter. And I see 3.99, remember we talked about if it's 9, and there's a bunch of 9s, we could round this to 4, 4 and negative 2. So we get the same answer this way. So now to find the x-intercepts. The x-intercepts, we have to go to our graph. And here is an x-intercept where it crosses the x-axis. To find them, you can go back to the calculate key on your calculator. And remember, another name for the x-intercepts are the zeros. So now I'm going to go left bound of one of my intercepts. So I'm going to go to one of them. And left bound, remember, if I'm hitting the left button, it's going above the x-intercept. So I could hit enter. Right bound, if I click right, I'm going to go a little bit to the right of it. I'll click enter and then guess. I'm going to click enter one more time, and it tells me one of the zeros is 2, 0. So that means one of the x-intercepts is at 2, is 2, or I can write it as 2, comma 0 if I was going to put the point. The other x-intercepts, I'm going to do exactly what I just did, except I'm going to go to the other one. I'm going to go to 0. So left bound is actually going to be below the x-intercept. Right bound is going to be above. And then guess, just click enter. And the other 0 is at 6, comma 0. Now to find the y-intercept, there's two ways to do it. Okay? When it is in standard form, and this right here is that's factor form, standard form, your c is actually the y-intercept. So I know it's going to cross the y-axis at 0, comma 6. If you don't trust me, we can go to our calculator. And actually, the way we can find out this, our calculator has a function on it, where if you go to second calc, there's one of the things that says value. And if you click that, it lets you choose any value for x, and it will tell you what the corresponding y value is. So here we know that the y-intercept is when x is 0, so I could type in 0, hit enter, and it verifies that y is 6 when x is 0. Well, now that I have all these points, I can go ahead and graph. I can graph my vertex at 4, 2, 3, 4, negative 2, 6, 0, 2, 0, and I could even go ahead and 1, 2, 3, 4, 5, and 6 graph the y-intercept. And then now I have a rough drawing. And you do want to go ahead and label the points. And then we're done. All right? So now we're going to do the next one. And here, we're going to do exactly what we did before. So we're going to go ahead and put this in standard form. So I distribute the negative x, or the negative 1x, and I get negative x squared minus 4x. So here in standard form, there's a b, there's an a, which is negative 1, but there is no c. So right away, since I know it's like plus 0, I know the y-intercept is going to be 0. So it's 0, 0. When x is 0, y is 0. To find the vertex, I could use negative b over 2a, but I'm just going to do it on the calculator. So now the equation is y equals negative x squared minus 4x. I think that was the equation. Yep. Click graph. To find now this one is a maximum, so I will go to second calc, 4 for maximum. Left bound is to the left of the vertex. Right is to the right of the vertex. And then last, just guess. And our vertex is at negative 1.99, so that's negative 2, comma 4. Which helps us get our line of symmetry, which is x equals negative 2. The x-intercepts. So we'll do what we did before. We'll find this one first. Right bound is above. One of the zeros is a negative 4, 0. And go back to second calc, or second trace, 0. So we're going to go to the other one now. We got to go all the way across. And I'm clicking the right button. You can see it's moving down the line, or down the parabola. So left bound is going to be a little bit above. Right bound is going to be a little bit below. And the other 0 is at 0, 0. Same as the y-intercept. So now I can graph my point, 0, 0. Vertex is at negative 2, 0. Negative 2, 4. 2, 3, and 1, 2, 3, and 4. And negative 4, 0. 1, 2, 3, 4. Now, the other way to see if there's a dilation is if you look in front of, or this is another way that your homework says, your homework actually calls it uh, a vertical stretch, which is just another way of saying, is there a dilation? And remember, when it's in standard form, the number in front of the x squared, which is -1, that tells you how wide or skinny the parabola is. And so the negative sign flips it, reflects it downwards. But the 1, there is no dilation here. In the one we just did, the number in standard form was 1/2 x squared. So there was a vertical stretch. It actually was wider. The dilation was 1/2. So the question is, there's a couple aha moments here. Okay? The question is if I gave you just the vertex form. So let me go ahead and write one of them down here. Well, actually, we'll do one at a time. If I just gave you the vertex form, would you be able to know what the vertex was? Would you be able to know what the x-intercepts were? Okay. So here, this was the original vertex form, and our x-intercepts were -4 and 0. Here, this was our original vertex form. And I'm going to go ahead and clean this up a little bit for you, just so you see the answers and the original factored form. And I called it vertex form again, but remember, I mean factored form. So look at the original. So you could pause it. Look at the original factored form and look at the actual x and y intercepts. And what you may or may not notice is that by looking at it already in factored form, you can actually figure out the x-intercepts. Right here, it's almost as if it's the opposite of what you see there. So here it says -2, but one of the x-intercepts was +2. Here it says -6, one of the x-intercepts was +6. The reason why is because they're zeros. If you set each one of the factors equal to 0 when it's already in factored form, you can actually get all the zeros. X equals 2, which is the x-intercept. X minus 6 equals 0. You get x equals, if you solve it, x equals 6. And the other one you don't use because 1/2 equals 0, that doesn't make any sense. So you actually only need the ones with the x in them, the factors that with the x, so you don't really even count the 1/2. So by having it in factored form, you can actually already know the x and intercepts. Now the vertex is actually, once you have the x-intercepts, remember the vertex is directly almost between the average of the two x-intercepts. So if you know that one of the x-intercepts is 2 and the other one is 6, to find the x-coordinate of the vertex, you just have to take the mean of them, meaning you do 2 plus 6 divided by 2. And that will get you the 4. Once you get the 4, you could just plug it back in and solve for it, to find the y-coordinate. But it's essentially the average. Now, the x-intercept is actually a little bit tricky. Now, we talked about if you actually do the standard form of this, the c is the y-intercept. But if you had the x-intercepts, which were 2 and 6, and you multiply all of the x-intercepts, so you have the 1/2, you got to actually, if there's a number on the outside, you have to actually multiply by whatever that number is. But if you multiply 2 times 6 times 1/2, you actually automatically get the y-intercept. Let me show you that on the other one. Okay. Here, the x-intercepts were -4 and 0. You could have got that by setting this equal to 0. If you set -x equal to 0 and solve it, you get x equals 0. And if you set x plus 4 equal to 0, you get x equals -4. So by having it in factored form, you can actually figure out the x-intercepts. And then once you know the x-intercepts, if I take the mean, -4 plus 0 divided by 2, you get -2, which is the x-coordinate of the vertex. And if you multiply -4 times 0, which are the two factors, you get the y-intercept, which is 0. So now let's see if you can actually take that information and do one on your own. Do this for practice. I want you to take this. So instead of, actually solving this out and doing the standard form, don't do that. Don't do the standard form. Don't worry about -b over 2a. I just want you to see if you can by the fact that this is already in factored form, how many of these could you get? So I want you to almost pause the video and then on your own, play the video and see if how many of these got right, okay? So the first thing I would have done, hopefully you got a chance to do it, is look at the factors. You have 2, x minus 5, and x plus 2. And if you set each one of those factors equal to 0, and solve each of them individually, you get x equals 5, x equals negative 2, and then this one we talked about, you don't really use because that doesn't make any sense. 2 doesn't equal 0. There you get your x-intercept. So if the x-intercept is 5, that's the point 5 comma 0. The other x-intercept is negative 2 comma 0, or just negative 2. So now that you have the x-intercepts, we can solve for the y-intercept, because we talked about if you multiply this times this, all the factors. So negative 2 times positive 5 times 2, that gets you negative 20. The y-intercept is going to be at 0, negative 20. The vertex, the x-coordinate of the vertex is the average of the intercepts. So 5 plus negative 2 divided by 2 is you get 3 divided by 2, which is 1.5. So the vertex is going to be at 1.5. To find out the y value, I can plug in a 1.5 there and solve it. So 1.5 minus 5 is negative 3.5. 1.5 plus 2 is 3.5. And then times 2. And if you multiply these two together, you will get 3.5 times 3.5 times 2. So 2 times negative 3.5 is negative 7. And negative 7 times 3.5 is 24.5. I'm sorry, negative 24.5. And now you have the vertex. Is there dilation? Well, not only do you know the number that if you don't change it to standard form, if we look back, the dilation, this one, when you change it to standard form, said 1/2 x squared. So this number actually tells you the dilation, the number in front of the parentheses. So here the number in front of the parentheses was a 1, negative 1. Here the number in front of the parentheses is a 2. So there is a dilation, there is a vertical stretch, and you would say it's thinner. It's dilated. The dilation is 2, or the dilation factor is 2. And then you can graph it by graphing the vertex, the x-intercepts, and the y-intercepts. I hope that helps.